Hi guys, so in this video we're going to look at games of chance. I'm going to take all of the probability stuff that we've been doing before, expectation of x, etc., and just relate it to real life problems or scenarios. Okay, so let's have a look at this example. It says two archers, Hugh and Mary, have a probability of 0.4 of hitting the bullseye as shown when they shoot the target. They decide to play a game. In this game they take turns to shoot the target. The first person to hit the bullseye wins. It's a maximum of 3 shots each, and if they haven't hit it, it's a draw. Okay, so Mary goes first. So let's determine the probability that Mary wins the game. So let's have a think what's going on here. So we want the probability that Mary wins. So Mary wins. Okay, that means that she either hits it on the first one, so Mary hits it on the first one, or Mary hits it on the second shot, or Mary hits it on the third shot. So is everybody happy? She either hits on the first one, the second one, or the third one. But that's assuming, of course, that Hugh doesn't hit it once Mary has missed. So you can see here there's three things that can happen. This, or this, or this. So we're going to work out this one. We're going to add it to this one because of the keyword or. And then we're going to add it to this one, again with the keyword of or. So Mary, the first one, she hits it. There's a 0.4 chance of that happening. So that's just 0.4. Dead straightforward. End of game. Or what could happen is Mary could miss the first shot. Now if Mary misses the first shot, that is 0.6. Because she's got 0.4 hidden. But that also means now that Hugh has to miss. So that's Mary missing here. Then Hugh has to miss. And then Mary gets a second shot, which she then hits with a 0.4. Okay. The third one then is that Mary misses the first one, so 0.6. That means that Hugh has to miss 0.6. Then Mary misses again with a probability of 0.6. But for Mary to win, Hugh then has to miss again with 0.6. And then Mary has to hit, which is 0.4. Okay, so run that through very, very quickly again. So for Mary to win, the first one, okay, she hits it straight away, 0.4, because that's what she has probability of. Not a bother, she's won. Or she could hit on the second one, which means that she misses, so that's 0.6. Hugh misses, but then she hits on her second shot. Or the third way of doing this is she misses, Hugh misses, she misses, Hugh misses, and then she hits the target. And all you have to do then, guys, is add all of those up. And if you add all of those probabilities up, you get an answer of 0.59584. So there we are. That's the probability that Mary wins if she goes first. Okay, so again, we're still assuming that Mary is going first. We're going to work out the probability that Hugh wins. So Hugh wins. Okay, so that means he wins on his first one. So Hugh on his first shot, just like before, guys, or Hugh on his second, or Hugh on his third. Now remember, Mary's going first here. So in order for Hugh to win on his first shot, Mary has to miss first of all. So that's 0.6 chance of Mary missing, and then that's followed up by Hugh hitting it straight away, which is a 0.4 chance. So that's the way he can win on his first visit to the game. Okay, so the or, so we're going to put plus for there. And now Hugh on the second time he gets to have a go means that Mary has missed, that's 0.6. He's then missed himself, which is 0.6. Mary has missed again, which is 0.6. And then he's hit, which is 0.4. Okay, so that means that he'd win it on the second. And then we've got the other or, so plus, and Hugh on the third attempt means that Mary's missed, 0.6. He's missed, 0.6. Mary's missed, 0.6. He's missed, 0.6. Mary's missed again, 0.6. And finally, he hits it, 0.4. Okay, so very quickly. So in order for Hugh to win the first attempt, Mary has to miss, he hits. Second attempt, Mary misses, he misses, Mary misses, he hits. Third attempt, Mary misses, he misses, Mary misses, he misses, Mary misses, and eventually he finally hits it. Again, if you add them up, guys, you'll get the total for this one. It's 0.3575504. Okay, Why is this not a fair game? Well, it's quite obvious here. Because they both have the same probability of hitting the bullseye, then the person who goes first has an inherent advantage, as they get to have a shot before the other person. So what would be a fair way to make the game? So it obviously favours, Mary, because she's going first. So the fairest way to make, or the easiest way to make this a fair game would be to flip a coin. So flip a coin to see who goes first. And that would be the best way to make this a fair game. Okay, if there's money involved, which generally there is when you're playing games, then what we can do to decide whether a game is worth playing, straightforward, is to work out the expectation of x. Now, if the expectation of x is less than 0, it's unfavourable to me or to the player. If it's greater than 0, it's favourable to the player. If it's equal to 0, then the game is fair. Now, really, really important, what you do is when you're trying to work out your expectation of the game, or the expectation of x here, you should always take into account any entry fee and possible losses and possible winnings. That's the way we work out expectation of x, and I'm going to show you how that works in the next slide. Okay, so remember, we always take into account an entry fee or a game fee or anything that we have to pay into the game, so that we can then work out the expectation of x. So it says here at Games Arcade you have to pay €2 to play a game of chance. In this game, 2 dice are thrown. If the total numbers of the dice are 2, 3, 4, 10, 11 and 12, you double your money. You get £4 back. If the total is 5 or 9, you get your stake back. If it's a 6, 7 or 8, you lose. Okay, so first of all, what's the random variable x going to be? Well, we can say let x be money after playing. Okay, so we're going to say let x be the money that you've got after playing. Okay, the next thing we need to do is work out if the game is going to be favourable or unfavourable. We'll do that in a second. And calculate the entry fee. We'll do that in a second as well for the last part. Okay, so in order to find if this game is favourable or unfavourable, we need to work out a probability distribution. And what I've done, or I've just basically copied this, and you can see here it's showing you all the different ways that we can get the different numbers that we're going to need in this particular game. So you can see here, we've done this before where we've drawn a grid like this, and we put the die 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, and 6, and we've added them up. So like 1 plus 1 is 2, and so on and so forth. So this is just another way of doing this. They've listed it instead. So here you can see there's one way that we can get 2, there's 2 different ways we can get 3, and so on and so forth. So it's just listing the outcomes and telling you the number of different ways. Naturally, we would expect there to be 36 outcomes, guys, because 6 by 6 will give us the 36. Okay, so first thing we need to do is to draw a table on what's going to happen here. So we've already defined our variable, so x, and then what we then have is the probability of x occurring. Okay, here we go. There it is. We've done this before. Okay, there's three things that can happen here. I'm either going to lose £2 because I don't win. I'm going to break even because what's going to happen is I'm going to get one of those numbers, for example 5 or 9, where I get my €2 is getting given back to me, which means that I'm not actually coming out with anything. And the last thing that's going to happen is I'm going to win £4. Okay, so if I get the 2, 3, 4, 10, 11 or 12, I'm going to win £4. But don't forget, we have to take off the entry fee for that. So I'm not going to win £4. I've already paid £2 in. So therefore, the last thing that's going to happen is I'm going to win €2 altogether. So there, guys, are the 3 things that can happen. And what we're going to do now is going to work out the associated probabilities. So the first thing we'll do is we'll look at if I lose. Okay, so if it's a 5 or a 9, you can see, if it's a 6, 7 or 8, we lose the stake. So 6, a 7 or an 8, so 6, 7 or 8, you can see here we've got 5 plus 6 plus 5. There's 16 different ways. You can count them if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different ways of getting a 6, a 7 or an 8. Okay, so there's 16 out of 36. So let's just put the probability down there. So 16 out of 36, I'm going to lose. Okay, it then says if I get a 5 or a 9, then I get my money back. So 5 or 9, so let's have a look. 5, 1, 2, 3, 4, 9, 1, 2, 3, 4. So that's going to be 8 out of 36. And then if I get a 2, 3, 4, 10, 11, 12, again, you can add them up, guys. 2, 3, 4. So 1, 2, 3, 4, 5, 6. And times by 2, that's going to be 12. So that's going to be 12 out of 36. Okay. Remember, make sure, just very, very quickly, add everything up. Make sure that all those probabilities sum to 1. So we've not made a mistake. So 16 plus 8 is 24. 24 plus 12 is 36. So all of those add up to 36 over 36, which is 1. So therefore, I've not made a mistake. Remember how we worked out the expectation of x in the previous video? All we did was we said, okay, let's do x by p of x next. And we just added an extra column. So an extra row. And we did minus 2. So remember, we do minus 2 times this. So let's work that out. That's minus now going to be minus 32. I do it in blue. It's minus 32 over 36. 0 times 8 over 36 is just 0. And then we're going to get 24 here because 2 times 12 over 36 is 24 over 36. Remember, the expectation of x is all of these added up. So we're going to add those up. Notice we've got negative here and a positive here. So we're going to get minus, as you can see here, when we add these up, we're going to get minus 8 over 36. Okay, and remember that there now is my expectation of x. Okay, so that's what I'm expected to get. You can simplify that if you want, boys. And if you do that, your expectation of x is now going to be equal to minus 2/9. Okay, divide both top and bottom by 4. Okay, what does that actually mean? Well, based on the previous slide, we're saying the expectation of x is a negative here. If we put that as a decimal, it's going to be a minus 0.22. Okay, which means that in the long term, i.e. if I keep playing this game over and over and over and over again, what's going to happen is I'm going to lose, on average, 22 cents per game that I play. Now, remember, that's the long-term average, guys. If I play this once, of course I could win. If I play it twice, I could win. If I play it 3 times, I could still be up. But the long-term average, and this is what casinos work on, etc., the long-term average is that this is going to cost the player 22 cents every single time on a long-term average. So on a long-term average, it's going to make 22 cents out of this game every single time somebody plays it. Okay, so let's have a look at part 2. Part 3, sorry. So let's calculate the entry fee that would make this a fair game, assuming that you win €2 for 2, 3, 4, 10, 11 or 12, which is exactly what we have at the top there. Your entry fee stake is returned for 5, 9. So it's exactly the same game, apart from we don't know what the entry fee is. So let's just say for part I here, so let the entry fee be equal to y. Okay, or some variable, doesn't matter. The only reason I'm not chosen x is because we're using x at the top there. So again, what I have here is, for this time, what we have is our x's are the same. So we've got x, it can either be a minus 2, it can be, sorry, a minus y, because that's what we're going to lose. We don't know what the entry fee is. Let me just change that. So minus y, I don't win anything, or I win €2 because it says that you win €2 here. Okay, let's work out the associated probabilities are exactly the same here. So we've got probability of x, okay, is equal to the first one for the minus y is going to be the same as the minus 2 here. So it's 16 over 36. Okay, so 16 over 36. 0 here was 8 over 36. And the last one there was 12 over 36. And what we're trying to do is trying to say what we want is to make this a fair game. So if it's a fair game, that means the expectation of x must be equal to 0. So for fair game, the expectation of x must be equal to 0. So all we're going to do now is multiply this by this, plus this by this, plus this by this, and set it equal to 0. So what we have then is the following. We have minus 16y over 36 plus 0 by 8 over 36 is just 0, plus 24 over 36 must be equal to 0, which means that minus 16y plus 24 is equal to 0. 16y is equal to 24, and y is equal to, I think it's 1.5, yeah, 1.5. Okay, so the fair price for this, where the expectation would be equals this, if this would be a totally fair game, then the price for entry would be €1.50. Okay, so that means that the fair price would be €1.50. Okay.